Welcome to everyone. Today we want to discuss scalar and vector product. It's very simple. Just consider two vector. Suppose a vector equal to 2i cap plus 4j cap plus k cap, and b vector equal to just I cap minus 2j cap plus k cap. And we want to find the scalar product. Scalar product means a vector dot b vector equal to generally formula a mod of b into cos theta, where theta is the angle. Suppose a vector along this direction and b vector directed along this direction, angle between them theta. So in this case, the scalar product or dot product of two vectors can be represented by this formula, and we can write from this a b cos theta, which is scalar quantity. Therefore, dot product of a vector b vector is a scalar quantity. So this product is also called scalar product, or also have a dot, so also called dot product. And we can write from this equation cos theta equal to a vector dot b vector divided by ab. This is the formula to find the angle between a and b, important formula. And suppose we want to find the angle between a vector and b vector. So in this case, first of all, need to find the magnitude of a and magnitude of b, as cos theta equal to a vector dot b vector divided by ab. So first of all, need to find the a vector dot b vector. So a vector dot b vector equal to 2i cap plus 4j cap plus k cap dot I cap minus 2j cap plus k cap. So we can get dot means 2 into I dot I cap dot I cap. This dot is this dot, and plus 4 and j cap dot j cap, 4 into minus 2, 4 into minus 2 j cap dot j cap plus k 1 into 1 k cap. Remember, I cap dot j cap equal to j cap dot k cap equal to k cap dot I cap. That means the mutual perpendicular unit vectors, where I cap is the vector component unit vector along x-axis and j cap is unit vector along y-axis, which is already discussed in our previous lecture. And k cap means z direction, perpendicular to this two plane, x, y and z, perpendicular to this plane. So we can write j cap along this direction and unit vector along this direction, j cap k cap means x I cap, y along j cap and k cap, they are perpendicular. I cap and k cap perpendicular. So I cap dot angle between I cap and j cap also perpendicular. They are mutual perpendicular. So we can write I vector j vector by this formula: magnitude of I into magnitude of j into cos 90 degree, because 90 degree the angle between I cap and j cap. So cos 90 degree 0. So I cap dot j cap 0. So similarly, j cap dot k cap dot I cap or k cap dot j cap, everything, whichever dissimilar vector is 0, and I cap dot I cap means mod of I into mod of j into an angle between I cap and I cap. They are in same direction, means cos theta 0 degree. So this is 1, and magnitude of unit vector always 1. So we can write I cap dot I cap equal to 1 equal to j cap dot j cap and k cap dot k cap. So remember this formula. So we have neglect I cap dot j cap, I cap dot k cap, all are 0. Only consider I cap dot I cap, j cap dot j cap and k cap dot k cap, which are never 0. So we get from the dot I vector dot b vector equal to 2 into I cap dot I cap 1 minus 8 to 1 plus 1. So we get minus 5, and from this equation 1 we get cos theta is the angle between AB, A vector dot B vector minus 5, and mod of A, magnitude of A equal to, we get mod of A equal to root 2 square plus 4 square plus 1 square equal to 4 plus 16 plus 1, 21, and also magnitude of B similar way, root 21 and root magnitude of B 1 square plus 2 square, which is minus 2 whole square equal to plus 2 square equal to 1 equal to, from this equation we get minus 5 divided by root 21, root 1 plus 4 plus 1 equal to minus 5 divided by root 21 into root 6. So cos theta equal this below, and theta from this equation we get cos theta equal to minus 5 divided by root 21 into root 6, or we get theta equal to cos inverse minus 5 divided by root 21 root 6. So by this way we can get the angle between two vectors. Things need to be considered. Suppose this is the direction of A vector and this is the direction of B vector, an angle between theta. So the component of B along A we can write B cos theta. So A vector dot B vector means A B cos theta, or B cos theta is the component of B along this direction. So you can write A into component of B along A. In similar way, B dot A we can write B A cos theta, or component of A along B, or component of A along B. We can write in this way A vector is the B vector and this angle theta. Then we can write component of A along B, A cos theta. So this means the both are scalar, and we can also write A vector dot B vector equal to B vector dot A vector. These two are equal. Okay. Now consider vector product or cross product, which can be represented by A vector cross B vector equal to mod of A into mod of B into sin theta into n cap, or n cap is the unit vector perpendicular to both A vector and B vector. Suppose A vector directed along this plane and B vector directed along this plane on the plane of the paper. So n cap, the direction of n cap depends on A cross B, means A cross B. That means two vector, A vector and B vector. If A cross B means A cross B along this direction, the anticlockwise direction. So in this case of anticlockwise direction, if we round a screw along the anticlockwise direction, the direction of the screw will be upward direction. Also, this can be represented by thumb. In anticlockwise direction, the anticlockwise A vector cross B vector, the direction of unit vector will be upward, the thumb direction. And in the clockwise direction, if B cross A, then direction will be along the down. So we can write n cap is the unit vector, A cross B means n cap upward, and B cross A, suppose B vector A vector, B cross A, B cross A, the direction of screw down. In this case we can write as minus n cap. So the A cross B not equal to B cross A, because A cross B directed upward perpendicular to the plane of the paper, and B cross A directed downward perpendicular to the plane of the paper. Those are opposite direction. So we can write B cross A equal to B vector mod of A vector sin theta into minus n cap, or this is another unit vector but directed opposite to the n cap. So we can write A vector cross B vector not equal to B vector cross A vector, because one is upward direction and there is downward direction, both are opposite direction, and sin theta is the angle, or theta is the angle between them. So we get across B is a vector quantity. So this is also called vector product, or as a symbol cross sign, so also called cross product. So how can we now calculate in this case? Suppose a vector equal to 2 I cap plus j cap minus k cap, anything that B vector equal to 4 I cap plus 5 j cap minus 6 k cap. Suppose these two vectors. So in this case, first of all need to understand about the multiplication of I cap, j cap, k cap. So we all already know that angle between the I cap, j cap and k cap, where x, y and z is perpendicular to each other. Everything perpendicular to each other. Angle between I, j and j k are 90 degrees. So in this case, formula I cap cross j cap, mod of I cap, mod of j cap into sine 90 degree, angle between them, into unit vector n cap. So now I cap cross j cap, the anti-clockwise direction. So in this case, upward direction, it will be upward positive z direction. So n cap will be positive k. So in this case, this is also 1, 1, 1. All these are 1 into k cap. So we can write this is k cap. I cap cross j cap equal to k cap. In similar way, j cap cross k cap equal to I cap, and k cap cross I cap equal to j cap. This can be written as by a triangular formula, where we can write as I cap, j cap and k cap. If we cross product the I cap cross j cap, then we get k cap. But j cap, the clockwise direction is positive. In the clockwise direction, positive. So I cap cross j cap equal to positive k cap. But j cap cross I cap will be negative. The anti-clockwise direction negative. So you can write j cap cross I cap. J cap cross I cap equal to minus k cap. The clockwise direction cross product I cap cross j cap positive k, and anti-clockwise direction j cap cross I cap cross k cap all are negative. So this need to be remembered. So by this formula we can write from this equation. First of all, how can we get the cross product of I cap? The easiest way is the determinant process. And now how to get the determinant? I cross B equal to first of all need to write I cap, j cap, k cap. Then component of I cap of A 2, and component of j cap of A, which is plus 1, and component of with k, component of A with k cap minus 1, and then B, component of B, I cap component 4, and j cap component of B 5, and k cap component of B minus 6. So this is determinant. In this case, to find the determinant, I will be positive. Then I cap, this need to be skipped, and the multiplication will be in I cap. Then I cap from the I cap, this need to be skipped, determinant, and we can write 1 minus 1, 5 minus 6, and the second. So get I cap into this term, and for j cap it will be negative, minus j cap, and we will skip this j along the j terms, we will skip. Then we get 2 minus 1, 4 minus 6. We can write 2 minus 1, 4 minus 6, and plus this will be positive. The first positive, then negative, and positive. K cap equal to, now this k cap will be skipped, and we get 2, 1, 4, 5. We get 2, 1, 4, 5. Now multiplying this, we get 1 into minus 6, and minus, this minus will be applied in everything case. 1 into minus 6, then minus into this minus 5. Okay, and minus j cap, this will be minus 12, and minus 4. This minus will be always come, plus k cap, then this will be 5 into 2 10 minus 4 into 1 4, and this from this we get this 5 plus minus I cap, and this will be plus 4 minus 8 minus minus plus plus 8 j cap, and this will comes 10 minus 4 6 k cap. So we get A vector cross B vector. This is the vector quantity, also having unit vector. So how to find this unit vector? By applying formula A cap equal to vector divided by magnitude of mod of this below. We can get also unit vector of A vector cross B vector. Now you can also try yourself by calculating B vector cross A vector and check whether B vector cross A vector equal or not equal of A vector cross B vector. Also you can also calculate by yourself unit vector of B vector cross A. Suppose A cap is the unit vector of B vector cross A vector divided by magnitude of B vector cross A vector, and also check angle between A cap and A1 cap equal to 180 degree. This is unit vector of A vector cross B vector, and this is unit vector of B vector cross. And we also can be check the angle between this 180 degree by A cap dot by this formula A vector dot B vector equal to AB cos theta. By this formula you can check the angle between them 180 degree. Also remember that unit vector of I cap cross I cap equal to J cap cross J cap, because the angle between I cap and I cap is 0 degree. Same, I cap and I cap is 0 degree. So sin theta is 0 degree means 0. Also K cap same vector, the cross product of same vectors equal to always 0. Okay. Now we will discuss another important things. How to find the component of a vector along another vector. Suppose we want to find the component of A along B vector. That means this is A vector and this is B vector, angle between them theta. The component of A along B, A vector along B vector, component of A along, that means the vector having different component. This is the maximum below and decreasing with angle theta. So how to find the component along B? This is can be calculated as A vector dot unit vector of B along this direction. That means how to find this? We know the component A cos theta along this direction, A cos theta. So how to find this A cos theta below? Actually we can write A cos theta, actually A theta. So to find the A cos theta, you can get from A vector dot B vector equal to A B cos theta formula. From A B cos theta formula, you get A vector dot B cap vector. A into B cap, magnitude of B cap equal to 1 into cos theta. Theta is the angle, and this is the B cap unit vector along B cap direction, and unit vector along A cap direction is so we get A cos theta. So this is the component of A along B. So we can write A vector dot B cap vector equal to A cos theta. So how to find the component of B along A? We can write B vector dot A cap. B vector, that means the just dot product with the unit vector along this direction. This is very simple. So to find the component of C vector along D, we can write C vector dot D cap. D cap is the unit vector along D. So suppose C vector equal to I cap plus 2j cap minus k cap, and D vector equal to 2I cap plus j cap plus k cap. Suppose this, and we want to find the component of C along D. So in this case, C vector dot D cap. Now first of all we need to calculate D cap, the unit vector along D. So D cap equal to D vector divided by mod of D equal to 2I cap plus j cap plus k cap divided by mod of D means 4 plus 1 plus 1, and that's dot product with this we get I cap dot 2 plus 2j cap minus k cap dot, this is 2I cap plus j cap plus k cap. equal to root this 6. So that dot product I dot I, 2 into I dot I plus 2 into j dot z 1 minus k dot k divided by root 6. So equal to 2 plus 2 minus 1 divided by root 6 equal to what? Means 4 minus 1, 3 divided by root 6. This is the component of C vector along D vector. Now let us do some numerical problems. Suppose let A vector, first numerical problem, A vector 2i cap plus 3j cap plus 4k cap and B vector, find the angle between them. So how can we find this angle between them? Need to formula A vector dot B vector equal to AP cos theta. So just cos theta equal to A vector dot B vector divided by AB. So first of all need to dot product as we have already discussed, and the magnitude of AB, and we can get the angle between them. So this is the example 1. You need to do yourself in your home. So just practicing will get easily understood how to solve this problem. Prove that second problem. Prove that A vector dot B A cross B equal to 0. So A vector dot A vector cross B. So how can we prove this at 0? We know the A cross B cross product and angle A cross B, we have already shown that, and you can write A vector A B sin theta into n cap, where n cap is the unit vector perpendicular to both A and B. A vector and this is B vector. So A cross B means perpendicular to both A and B, means this plane A cross B, and perpendicular to both A B is perpendicular to the plane of the paper along this direction n cap. So angle between A and n cap is 90 degree. So we can write, this is scalar quantity. So we can write A B sin theta A vector dot n cap. Now in this case we can write A B sin theta, where theta is the angle between them, and A vector dot n cap. N cap is the perpendicular to A and B. So this is 90 degree angle between A vector and n cap. So this can be written as A into n means mod of n 1 into cos 90 degree. So A vector dot B cos theta 90 degree. So cos 90 degree is 0. Then whole quantities becomes 0. So A vector dot A cross B equal to 0. Now the third problem. A vector 2i cap plus 3j cap plus 4k cap and B 4i cap, find the A cross B. So we can get A cross B by determinant whatever we already discussed in k cap. We get 2, 3, 4 and 4, 3, 2. So I cap into this 3, 4, 3, 2 plus minus j cap. First plus, then minus, and then again plus. 2, 4, 4, 2 and plus k cap, and k cap means this script and this below 2, 3, 4, 3, and by calculating we get A cross B. Now the fourth problem. If A, B, C are mutually perpendicular, show that C vector cross A vector cross B vector equal to 0. They are mutually perpendicular. That means, so we can write this perpendicular means, suppose x, y, z axis A, B and C perpendicular to A and B. The angle between A, B, B, C, 90 degree, all this is 90 degree. So A cross B means C vector cross A cross B, A, B sin 90 degree into n cap, where n cap is the unit vector perpendicular to both A and B, which is along C direction. So we can write A, B sin 90 degree means 1 into C vector cross this C vector. There is only 2 vectors. These are scalar. So this will come in front outside of bracket, and the vector will product with another vector C n cap. There is vector product, cross product. So angle between C vector and n cap is the perpendicular to both AB, which is along the C. So angle between them is 0 degree. So you can write AB C mod of C into mod of n cap sin 0 degree cross product. So sin 0 means 0, then becomes 0, which is proof. So is the converse true? Yes, true, because perpendicular vectors always 0. That means A vector cross B vector cross C vector equal to B vector cross C vector cross A vector equal to then A vector cross B vector cross C vector, everything, or B vector cross C vector cross A vector, all are 0. By this way we can prove this. Okay, now another problem, the problem number 5. A particle moves on a given straight line with a constant speed. On a given straight line, a particle moves in a given straight line with constant speed b. At a certain time, it is at point P. Suppose this point is P after a particular time. On a straight line path, this is straight line path. O is fixed point. Suppose O is fixed point, so that OP into cross B vector is independent of the position of P. So we get OP along this direction and B vector, the velocity vector, also along this direction. So OP, angle between OP and B vector equal to 0 degree. So we can write OP cross B equal to mod of OP into mod of B into sin 0 degree. Angle between them 0 into n cap is the unit vector. So sin 0 degree means whole quantity is 0. So whatever the value of OP is not depend on the value 0. It comes always 0. So